these and many other misconceptions even among people who are teaching at the university level. So this is what happens when you learn the facts of science and not how to figure out, what actually science is. Oh, sorry. So what is wrong with this whole process is that I think I'll best be able to put it across by telling you about my own experience of learning science. I like science because mainly because I had to write very short answers for the exams. So I elected to study science because I thought it's much easier to pass papers, exams in science than in any other subject. But I also had the advantage of having access to other books, not just textbooks. So I read other things and also watched documentaries on TV and all, and found a lot of interesting things which kept my interest alive. So I continued to do my BSc and all that. And in BSc I found very good teachers. But till that level I had basically learned the way almost everyone of us learns science. And after going to college, of course, no one tells you the basics. They assume some foundational level and they go on to. So I realized that the foundation on which my knowledge of chemistry was based was very problematic, because it was only when I joined Eklavya and started working on this module on how to teach the atomic theory that I realized I don't know where the idea of atoms came from. So if you look at how atoms are taught perhaps in middle school or in high school, you're taught about ancient ideas about atoms, and then you're taught about the modern theory, that is Dalton's theory, as if it's just an extension of the earlier theory. The problem is that the ancient theory is about atoms, whether it is like Western or Eastern ideas, were basically used to explain change. So there was a school of thought which believed that nothing changes, everything is eternal. So, but you see things changing, you see rocks eroding, you see children growing up, you see people dying, you see earthquakes happening, so many things are happening. So how do you explain this change? So the earlier atom was a philosophical atom which was used to explain that the change that you see is superficial. Underneath you have eternal atoms which don't change. All change is explained by saying these atoms are just moving around, combining with some atoms at one time, some other atoms at other time, but atoms are eternal. And they use this picture of how do you get atoms. So you take any object like a brick or a chalk, and then you keep breaking into smaller particles and smaller pieces, and at some point you reach a unit of a brick which can't be broken any further. So this is the uncuttable atom. And you're taught about the modern atom in the same way. The teacher uses the same example, I'm sure. We'll take a chalk and break it and say, you tote jao. Finally, you'll reach a piece which can't be broken any further. But the problem is, and then you're taught about how substances react in constant proportions along with the same, at the same time that you're taught Dalton's theory. So the problem is that the law of constant proportions and all, it is trying to explain the law of constant proportions that Dalton arrived at the idea of atoms. And further, the modern atomic theory is also a useful theory in the sense that it gave rise to whole fields of studies. Like the first thing that Dalton did was he used the atomic theory and a lot of assumptions, some of them were proved to be wrong, to calculate the atomic weights from the weights of the reacting substances. Right? So once Dalton gave this idea, there were a whole lot of people using different methods to calculate the weights, atomic weights of different elements. Of course, different methods gave different weights, and initially there was a period of confusion where many chemists felt that items are very painful. It's better to just get into the idea. It's not of any use. It is just causing confusion. But ultimately, like all these things were resolved, and now and we reached a stage where atomic weight was taken as a defining feature of an element, right? So all this I learned why you get the idea of an atom only after I joined Eklavya. I mean, I had been using the idea of atoms. I could, when I was like Bhas was saying, I was doing organic chemistry and I had to imagine what molecules would be feeling in the surroundings depending on what the reagents are. All this I did, but I didn't know where atoms had come from. So, before this, let me just tell you that what research says is that children will not be able to, even if you tell them about atoms, children will not be able to appreciate what the modern atom actually means till they have a whole lot of chemical experiences. And the kind of experiences that they suggest is exactly what we find in the Bal Vaigyanik textbooks, which is developed as a part of the Hoshangabad science teaching program. So let me just take a little aside to tell you about HSTP, because I don't know how many of you heard the earlier lectures. So Hoshangabad science teaching program was developed to teach science through activities, and it was started in a few schools in rural, a very backward area, rural schools. And initially, of course, there were university professors and all, so they were using typical lab equipment to do the experiments. And then realized that it's not possible to keep the program running if you have, if you depend on very sophisticated equipment. So you can see from these pictures that they got the children to do titrations, no burette, no pipette, just use droppers and count the number of drops. So you do acid-based titrations by counting out, say, 10 drops of the solution in the base, add phenolphthalein, and then, you need to take the acid first. And then see how many drops of the base you need to neutralize the acid. And in the middle is one of my favorite pieces of equipment. This is a setup to produce and collect gases. So if you've ever done any experiments of preparing gases and testing them, normally you need a hard glass test tube. You fix a rubber cork, which is, you first have to use a borer to put a glass tube through it, and then you have to make the whole setup airtight, and then you have to connect a delivery tube. Here you have an injection bottle. Of course, the drawing is sadly out of proportion, but that's an injection bottle with an empty refill put through it, and that is connected using a cycle valve tube. And you just collect the gas by a downward displacement of water. So this setup is airtight and it's very robust. Injection bottles don't break very easily. So in fact, we used to even get children to use injection bottles in place of test tubes. Added advantage being that you don't need test tube stands. They're not very easy to break and you don't need test tube stands. And then this, of course, is familiar now because when we were working on the textbooks post NCF 2005, a lot of the Eklavya people were involved with the textbook writing, NCERT textbook writing. So chromatography and all is general part of the NCERT textbook, at least now. So, so we got the children to do all the experiments, and a wide range of chemical experiences were provided. So a brief look at what kind of experiences were there. So exploring the physical properties of different substances, and this is actually to understand that it is very difficult unless you've studied different substances, to know that a white powder is not the same as any other white powder. So you start by looking at the physical properties. You see solubility, you see whether things float or sink. You study, interestingly, there are also a lot of experiments on air, because this is actually, studies have shown that gas as a state of matter is the most difficult thing for children to comprehend, because dikhta nahi hai, so they feel it's nothing. The next step was studying the physical properties and using them to separate mixtures into the components. And this is actually the reverse of the route which is generally followed in textbooks, where you're taught about pure substances and mixtures. You're taught about elements, where you're told that elements have only one kind of atoms in them. Then you're told about compounds, where atoms of two or more elements are combined in a fixed ratio. And finally, you told about mixtures, where any number of substances can be combined in any ratio. There's no fixed ratio, right? But this is actually quite confusing. And it is also unnatural in a sense that what you find around you are mixtures. You need to use various methods of separation to get pure substances. And later on, when once you get pure substances, you further need to separate it any further into, say you have compounds, if you want to separate it into the component elements, you need to do chemical reactions. No physical method of separation is going to turn a compound into its constituent elements, right? So we start by taking mixtures and seeing how we separate them, what are the properties used in each method of separation, and this idea that after you have tried out all methods of separation, whatever you get, you can't reduce it any further, that is a pure substance. So an idea of this process of separation is a foundational skill in chemistry, which doesn't come out in the standard separation chapters. So we go from using separation to arrive at the idea of pure substances, right? Then, of course, we study the chemical properties of different substances. We prepare gases and study their properties, do various chemical, when I say we prepare, we get the children to prepare and prepare gases, identify them, and then you carry out a number of chemical reactions. So just yesterday, I think someone was telling me that there's a lot of confusion between, the teachers have a lot of confusion between physical and chemical changes. So this is because how do you know what is the final test to see whether a chemical change is taking place or not? You only know a chemical change is taking place if you are able to test the properties and see that properties which are not present in the starting material, whether it's a pure substance or more substances, have now changed, right? So unless you've done reactions and you've studied, okay, what the starting materials were something like this, look like this, smell like this, had so and so properties, were acidic, whatever, and then after the reaction you're getting a new substance, maybe you're getting a gas, maybe you're getting a precipitate, and the color is different, so many things. So you actually have to do a lot of chemical reactions and recognize how it's different from a physical change. When a physical change happens, the properties remain the same, right? Whatever the reactions which take place in one state would happen in the other state, whatever physical change is taking place. But when you have a chemical change taking place, you get new substance, one or more new substance with totally different properties. And finally, the most important thing is that we, like I showed you the titration thing, we get them to do quantitative experiments also. So unless you do quantitative experiments, you don't get to the idea of atoms, because like I told you earlier, once Lavoisier had identified that the law of conservation of matter, that matter is neither created nor destroyed in a chemical reaction. After that, people started doing a number of reactions and studying what are the weights of the starting materials and what are the weights of the final products. And that is when also this recognition came that gases may be taking part in reactions or being evolved in reactions. So unless you have you have a chemical balance of weights taking part in the reaction and the weights taking part and coming out of a reaction, and unless these balance, you know that there's something missing. If the weights increase, that means some gas is being added. If the weights decrease, that means some gas is being lost. So once the law of constant proportions came into being, people started taking very careful measurements of all the reactions we're doing. And then the law of constant proportions, did I say constant proportions earlier? Law of conservation of matter. Okay, then they arrived at the law of constant proportions. And of course, law of reciprocal proportions, but that is not as important to this idea. And it's trying to explain why you get constant proportions that Dalton arrived at the atomic theory. So we basically believe that this whole experience, that all these experiences that children get in middle school prepares them for the atomic theory in high school. And we have prepared this module on the atomic theory of matter, which follows the historical route to understanding atoms, and also reaching to the point where Dalton's theory got wide acceptance. So this is like one way of teaching a certain concept. To teach the atomic theory, you have to go through all these steps if you expect the child to understand and appreciate the atomic theory. So a lot of studies have shown that whenever you actually get children to do experiments and sit in groups and discuss them, and a teacher is there to help the children negotiate, it's not a direct link between a practical and a theory, because any expectation that children will do a couple of experiments and reach a theory is like very unrealistic, because I mean people did experiments for hundreds of years, and so many people thought to arrive at any of the theories that you learn in high school. So it's not reasonable to expect children to arrive at those theories, reinvent the wheel, so to speak. But with the help of the teacher in this guided discovery, they can appreciate what are the alternate conceptions which may be confusing them, and arrive at the and at least appreciate the right theory, not arrive at the right theory. So if you do activities in the classroom and you have discussions and children are sharing their ideas and bringing out all the questions and doubts, maybe you have better retention. So maybe they learn scientific facts. But does this result in the children being able to transfer these skills of questioning, observation, critical thinking, all that, analysis and all, to solve problems that they may come across in daily life? When faced with any statement, particularly some advertisement or something like that, do they question things? Do they ask for evidence? Do they ask, how do you know this? So this certainly seems to be missing. So in an attempt to do something about this problem of transferring the idea of the process of science into solving daily life problems, we used to conduct, not with children, but in teacher trainings, we used to get the teachers to do investigatory projects. So the process was that in the beginning of the workshop, we would get all the teachers to sit and get them to share all the questions that they've had regarding whatever, anything that has puzzled them, whatever. And we list all the questions, and usually we have a group of some 30-40 teachers in our workshops, and easily like some 60 to 80 questions come out. And then what we do is, after listing all the questions, we analyze them to see which of the questions we can address during the course of the workshop, which is about a week long. So of course, like some of those things would need equipment which are not available or very expensive or something. Some of them, maybe the time frame is not sufficient. Like for example, we had a question once, like how long would wheat seeds be viable? Like वो कितने साल तक germinate करेंगे? So obviously you can't test that in a week. So things which require very very complicated designs or something would be rejected. But still we would arrive at a few questions which we could hope to investigate during that period. And of course some questions were also rejected because it would not be a part of science. Like for example, there was a question on how is it that gold leads to people possessing power. So it is like, in Hindi it makes, I guess it makes more sense, कि सोने से वो दमदार कैसे होते हैं, something like that. I'm sorry, I don't know the exact thing. And then the question like, why is it that women use purses? So these would not come in the realm of science, so then you would leave them. And but of course we did take some social issues also, which we felt we should raise scientific questions about it. But we'll come to that. So after listing out the questions, we would select the ones which could be investigated, and then obviously not everyone's questions would have been selected, so we would form groups of who would like to join this person in finding out the answer to this question, and then we would get the group to sit and discuss what is the method they're going to follow, what is their hypothesis, what are they going to test, how are they going to study the problem that they posed for themselves. And we would usually have at least, if not full time, but send a resource person to spend some time with them and help them refine their refine whatever sequence of tests they have thought of. And then after all the groups have finished this discussion, we would get them to share it with the entire classroom, and then of course even the other groups would make suggestions on how their methods could be refined or whatever. So let me just give you an example of this, of course, what I just talked about. So after this we would try and over the rest of the workshop we would be all the groups would be trying to find the answers, and then at the end of the workshop they would present their findings. So the kind of questions, some of the questions which have come up, I just selected, you can take a look. Why are ice cubes cloudy? How can we get clear ice? I don't need to read them out, no? You can see it. So maybe you could just take a couple of minutes and think about whether you have any ideas of how you would go about finding out the answers to any of these questions. Interesting questions, no? These are questions, I mean, a lot of interesting questions. This randomly I just picked up a few. Of course, some of these investigations got written up in our magazine Sandarbh, which is meant for teachers. So I'd like to talk about the first one, Mahavari Mein Mahilayein, which is basically all the beliefs surrounding menstruation. So they decided, one group decided they would study it. So first they listed all the beliefs, if I remember, there is if a woman who is having a period touches jar of pickles, and the pickles are going to go bad. They're not supposed to water tulsi plants. And then in that particular training, there was this guy who said that, if any lady who's menstruating touches him, he would get a headache. So poor guy was harassed throughout the training. Like random women would go and touch him and say, I'm having my periods, and then ask him at the end of the day, did you get a headache or not? So it is I don't know, it's not a double-blind test, but because the person going and touching him knew what is going on, but he didn't know what is going on. So this is an attempt to see whether there is anything behind a very widespread belief. So of course the other thing is there. Okay, so this is what Eklavya has been trying. So one is figure out what is the best way, best sequence of activities to lead to any particular concept that you're interested in teaching, and then also going beyond that. And if you think about it, in school, especially CBSE schools, there is a large component, you get marks for projects. But projects have become big business. No one actually does. Very few schools carry out sincere projects. But it's a space which can be used to. Children have questions. Find out how you could investigate them. Unfortunately, that doesn't happen. While I was going through all this, then I came across this very interesting paper by someone called Melanie Trace King, I think. I will get the name exactly. So she has been teaching biology for many years before she realized that there is a problem with the way science courses are designed. Because there are a lot of science courses which, in India for example, everyone has to study science till 10th. So what is the purpose of that science course? Do you expect children to remember all the facts that you learned till class 10? So she felt it's no use expecting children to learn what we call the products of science, because then they would just be learning it to pass exams. So she developed this course which she called Science for Life. So the idea was that you don't teach the products of science at all, you only teach the process of science. So during her course, the focus was on critical thinking and science literacy. So she starts by getting children to recognize good science versus pseudoscience or bad science. So of course she is based in the US, so local things would be studied. Like in the US you have a belief in UFOs, which I don't think is there in India. In India we have a different set of beliefs. UFOs. So she starts by giving all the children an astrology based personality assessment, all the students taking a course. And they all read this assessment. I'm sure all of you have read your horoscopes in the paper or something. sometime or the other. And the children all agree that, yeah, it fits in perfectly. And then she reveals that everyone has got the same thing. Everyone's got the same set of statements about what their personality is like. So once the participants in the students in the class realize why she's fooled them, they realize how easy it is to be fooled. And then they are open to studying various examples of pseudoscience or bad science. So, for example, she looks at homeopathy and why personal anecdotes are not useful in leading to any understanding of medicine or what cures or what heals and things like that. Because basically, when you depend on your own memory, it is fairly faulty. For example, suppose I dream about Aparna and she calls me. I remember that. I do not count all the number of times when Aparna would have called me and without me dreaming about her. Nor will I remember when I dreamt about Aparna and she didn't call. But that one thing, no, that's basically the memory is being reinforced. I dreamt about Aparna, arey uska phone call aa gaya. So your memory is very faulty. We tend to disregard that. That is why you need very careful record keeping in science. Anecdotes don't work. You need to know how many times. Recent examples, I'm sure you all heard of किसी ने कोविड का वैक्सीन लिया 2 दिन बाद मर गया, right? Does that help you learn whether the vaccine is effective or not? Right? So you need to recognize. You need training in recognizing bad science, pseudoscience, to appreciate good science. Is what she says. Of course, she goes on to get the students to evaluate sources online, and she says then you become good consumers of information. You realize what are the good sources of information, what can be relied on, what kind of questions you need to be asking. Anytime you hear any statement, what is important is not what you think, but how you think, right? So she says that the science courses need to be designed not teaching you a whole lot of stuff, but how to think. So basically, if you're scientifically literate, this is what you're supposed to be able to do. How many of us pass this? I'm not very sure. So, right. So after all this, you're still faced with a whole lot of claims. You hear various things. So what are the options before you? So for example, have you heard of a god who sleeps on a raft of serpents?
God who sleeps on a raft of serpents.
Huh. Suna hai? Vishnu. There's one more god. A South Indian god. South American god. Inca god, Kontiki. Son of the Inca sun god. He is supposed to travel on a raft of serpents. Okay. When you hear a story like this, what are the possible responses? हो ही नहीं सकता. Yeah, हाँ बिल्कुल possible है. God, he can do anything. And or maybe wonder where did this idea come from that you could have a raft of serpents. So I just elected this story. I mean, there are a lot of stories which have been investigated, but this particular story, there's a book called Kontiki Expedition, which is very interesting. There's this person who had this belief that you have these islands in the middle of the Pacific Ocean. And his theory was that the population, that those islands were populated by people going from South America. So he had descriptions made by the Spanish people of Inca ways of making boats using particular wood, and they would cut these huge logs of wood and tie it together by ropes. So he made a boat according to, this is a picture of the boat that he used. Sorry, I should point there, no? So this is the picture of the boat that he used to, he made the boat according to their specifications, and he went from somewhere along the coast of South America to one of those islands. He ended up crashing there, but he made it all the way across. I mean, there's a team of people there. And then he says of his experience that in the sea with all the waves, these logs would move. They are just tied. So they would move. And it would seem as if you're sitting on something alive. So he says maybe that's where the idea of sitting on serpents came from. So when you have any kind of, someone tells you something, don't believe blindly, don't reject it totally, but try and figure out how, why, where it might have come from. So, I guess that's all I have to say. I hope time is okay?
Yeah.
Okay. Shall I close this?
No, if you want questions.
Questions, yes.
Yeah, please. Should I have a mic for him so that it is captured?
it's fine.
It's fine? Yeah, go ahead.
I love your idea, but I should say I really like your idea.
Which idea?
The idea to
Do experiment?
use science during the learning process, people should do experiments and so on. But I said I loved it because the next part is not that nice. So,
Go on.
so the issue is that like as a student here, there is a issue of money, right? Like if you are
Issue of
money, like
money.
issue of funding, like it's an amazing idea to let students do experiments and figure out things as they learn things. Like it would be amazing if I get to feel oxygen and so on and so forth, but it needs a lot of funding. And, so on that aspect, like how one would address it, like.
You want me to answer where funding would come from? Actually, the whole point of the HSTP program was basically that it was very low cost.
Yeah, so I think
We were
this
using a lot of locally
I think you should comment on this notion that
experiments
most
are
people
expensive.
have that experiments, especially when you're looking at experiments at the school level, need not be expensive. I mean, you can actually do it with
You can
at very low cost.
you can find a lot of locally available material, a lot of waste material which can be used to do experiments. In fact, Bhas worked on one of the modules for us on heat, and you've used calorimeters.
Yeah, I think
So calorimeters are made of copper, which is very expensive. So we just used styrofoam cups. You put 2 cups. It's fairly robust experiment. You won't get, of course, get perfect. I mean, you don't prevent heat loss totally, but you do get a sense of if you mix water 2 different temperatures, what will be the temperature of the mixture be. So, I mean, a lot of low-cost alternatives are there. Like, for example, in the HSTP program, the teachers themselves used to come out with a lot of suggestions about what could be used. So, instead of needles, they suggested using, there's a tree called baboon, it has got thorns. So, they said you can use that instead of needles. So, a lot of things you can, especially in middle school science, you really don't need very expensive stuff. I guess most expensive thing would be buying chemicals,
Or a
and maybe
commodity.
buying cells to do the electricity experiments and things like that, which is actually not much. I mean, if you work out the budget, it's not much.
And,
So
and
there
you
is
see,
a
with smart ideas, and if you have people who invest their attention to developing experiments, it's actually possible to develop experiments which are fairly sensitive. Not necessary that low cost experiments are very dull or insensitive. I mean, insensitive is not human insensitive, but sensitive to changes. Kind of experiments. For example, I mean, I'll just tell you one example from the book that she's talking about. So you normally think of expansion of a solid as being something that is very, very tiny. I mean, you can't change the temperature of something by 200 degrees centigrade to see a significant expansion.
Okay.
But you can design an experiment in which that expansion can be observed without any sophistication. It will probably cost you 5, 7, 8 rupees. We'll talk about that. I'll show that. So even things in chemistry like the idea of a mole or how many atoms there are in a mole, these seem like very difficult questions. How do you get some ballpark idea of how many atoms there are in a mole or how many molecules there are in the mole. You can do an experiment which gives you a rough idea. At least, I mean, you get a sufficient idea that this is not a number you can easily comprehend. So this is possible. Yeah,
I think you have a question.
Yeah, so I really appreciate all the things happening under Eklavya. I just wanted to know what is the scalability of all this. I mean, for example, uh, the models or the instruments, whatever you are designing in that week that you said that you selected some specific questions that you can actually sit with student, discuss, and you can actually solve or come up with some solution by using the whatever the material is available, which is not so expensive. So is there a way to actually most of the schools in India can take advantage of this effort, and
Okay.
are these things scalable?
See, the only thing which is stopping this from happening in all schools is having sufficiently motivated and well trained teachers. Because if you see teachers in schools, they all studied in colleges where they have not done practicals. They have not done practicals in schools. I said my practicals hota hoga, but there are a lot of colleges where you can do a BSc without doing any practicals. You just fill out the records. So when they have not done activities, they don't know how to get children to do activities. Plus the conceptual understanding is lacking. We had that list of questions, no? So, if their concepts are not clear, how do you expect them to teach the students? So you need a lot of investment in the capacity building for the teachers. That is the biggest hurdle. It's not materials. Materials are, I think, much easier to manage. It is scaling up the capacity building for the teachers to reach all the children, which would you need resource persons to be to work with the teachers. So that is what I see as a hurdle.
So all these things are documented. Whatever is happening under Eklavya, is it getting documented so that maybe some small pamphlets which are readable in local languages can be published and sent to schools where kids can parallelly
Actually,
learn?
most of the work that we did was is being published in Hindi, because when we started work, you have plenty of materials in English, but there's a paucity, there still is a paucity of materials in Hindi. So there was a conscious effort to develop materials in Hindi. When we were working with the ashram shalas in Maharashtra, we translated a lot of materials into Marathi. So that needs to happen. It is not there in all languages, but yes, Hindi, it's there. And you have like you're saying, we have like materials for children, we have materials for teachers, we have issues. We address issues at various levels. So materials are there, and all of it is available for free on the website. Please take a look.
So you also said that some of the people in Eklavya are also involved with textbook writing.
This is in 2005 when NCF 2005 happened, and the whole textbook writing exams, textbook writing experience exercise happened. That time a lot of our people were involved in the social science, in the language textbooks, in the science textbooks. So a lot of the middle school material, a lot of the Balvaiganik experiments are there in the NCERT textbook.
Okay. So what is the scenario now? Is there a way where actually some of these experiments or your findings or kids' experiences of all these discussions and all, some of that part can be actually incorporated as a part of curriculum?
See, we are willing to do it, but the willingness to incorporate it in the curriculum also has to be there. Because if you look at the trend today, science education, we have never gone beyond, we've tried, we developed an entire curriculum up to class 8. After that, we've only developed some modules for class 9 and 10, not even an entire syllabus. Though we do have ideas about what the syllabus should be like. But going beyond that, it seems like a futile exercise, because the entire focus in 11-12 is not on teaching science. It's on getting the students to prepare for the entrance exam. So the content is,
I agree with you.
Yeah, so I mean, what will you do? I mean, the pressure, social pressure is so much. I mean, no board will be willing to consider what the children will be able to understand and give sufficient time for the children to, understand and proceed. Instead, it's like just, hammer in as many facts as possible and then test them for it. So,
Your experience, what would be the right standard in which actually this kind of thinking and maybe reading material should be available to kids,
uh, kind
so
of,
that they can learn how to learn. I mean, you understand? Maybe there is a problem with teachers how to deliver the content because they are not themselves comfortable with the content, right? So how can we actually teach students how to learn? Like maybe by the efforts that you are taking, maybe it's a way to actually teach kids how to learn, right? Or how to understand some scientific concepts.
Okay, couple of problems with that. One is that learning happens in a peer group. It is very rare that a child will be able to sit and read on its own and understand something. Peer group is necessary, open discussion is necessary, and a teacher to guide the discussion. I mean, this is not just me saying. There are a lot of people who go by that. And beyond that, you have a lot of studies done on what children can understand at each stage. Plenty of studies on what are the confusions children have and how they can be avoided. But to put all that into practice, you need time. You can't teach 25 chapters and be able to, and have the children actually learn something. Then they'll only learn things to pass exams. They will not actually internalize anything. So, I don't think that, just sitting in a cave by yourself and reading a book, you'll learn anything. Science is a social activity, so learning science is also very much a social activity. And I think a teacher is very essential. So you can't get away with avoiding teacher capacity building.
Yeah.
And ensuring that, teachers are there in the schools and taking classes.
Okay, thanks.
I can hear you. I'm not sure whether.
So I was just wondering, you showed this process of experimentation at the beginning, leading to whatever goes. So you showed this process of experimentation being critical. This has been tested during the program within X number of students.
Actually, HSTP itself, the documentation is not very good. Some of it has been done, but not very good. But there are a lot of curricula which are based on this, discovery method, kind of, so to speak. So you had the Nuffield thing in UK, and you had in the US you had chem study and biological sciences curriculum. So all those, they have been studied in great detail.
The question that I was getting to, sorry. So I was saying that it's been so either this one or the ones that you mentioned would have been tested with X number of students. Has there for doing a certain experiment in you have a certain number of days and you do a certain number of experiments? Do any of these curricula talk about repeating experiments within a time frame? Because even if you want to reach all students are not always available to learn. Does anybody talk about this is a set of experiments that you repeat it, because when you go to the next one, some students will ask you about the first one. I mean, I understand it's a lot of time and teachers don't have time. There are all kinds of things. But I wonder whether that sort of questions are ever asked. That is repetition allowed?
Like when we have tried out things with students, and when we do it with teachers also, often what happens is in a particular group something goes wrong and their results are very different, or sometimes you don't see any pattern at all. And actually that's also an essential part of the process in a way, because usually when you are giving the instructions on how something is to be done, people don't listen. They're so excited when they see things and all, they start doing something. So the first round you make mistakes, and then so that's the point where you drive home, what are the precautions to be taken, and then you get them to repeat it. So when we get them to do experiments, I would not say whether it would be possible. I mean, we've never tried. Okay, आज नहीं हुआ तो कल फिर से करके देखते हैं. But in that session, they certainly do get to do the experiments till they are able to get consistent results. Is that what you're asking?
Sort of. But I was just wondering that it may not even be the same day. So whether,
So, I
because
mean,
since we're
within
talking
that
about
session,
cognition and
within
all
that
these things are coming up,
huh.
I wonder whether it's even a question that's asked. I mean, I don't know. So I was just...
No, so the thing is that the kind of experiments that we are encouraging students to do, most of it can be done without supervision. So once they've done it themselves, and if they feel like doing it, they can do it on their own. Maybe not in the same classroom. I mean, when the class is going on, if they've moved on to some other point. But yes, in when we do the teacher workshops, earlier when the HSTP program was running in schools also, when we would do the teacher workshops, we would tell them that this is what they're supposed to do with the students also. Make sure that every student was able to understand the point of the experiment and do it, be able to do it. So not just ki ek baar kar liya, now let's do the next experiment. Question.
Yes, so as you said, like we go from practicals to understanding theory. But in my case, like as I have learned theory till class 10th, 11th, and then in 12th standard, I started getting exposure to experiments, and I'm glad that I'm at ISER now. But I have a small sibling, I mean, my brother, who is in 9th standard, and he a lot of times asks me questions, and I try to explain him from my side, but then he ends up on saying this, like, this was his question, which I felt this should not be the case. Why Newton created gravity? Why did he encounter something like falling off apple? It created my life hell. So this is what he feels, and I want him to appreciate the science, the way they have discovered things. I try to explain that, see, if this hasn't have happened, so we would not have these applications. But then he's not that convinced. So at my level, how can I try to convince him, or at least make him appreciate the beauty of science?
So first you have to convince him that Newton didn't invent gravity. That's the first thing to do. Okay. It's actually, there's a whole book written about how Newton actually invented gravity. Before Newton there's no gravity. So maybe he's on the right line. Yeah, it's really a difficult question to... you would have to do a whole series of things, no? Because gravity didn't come out of any one experiment. Newton is trying to put together so many things. Like he went one step beyond Galileo. Galileo is just looking at how things move on Earth, and then Newton realized that the same things apply to motion out in space also. And that's where gravity, and he used, I mean, he didn't invent it, but he kind of defined what is happening. So I maybe if I talk to your brother, I'll be able to see where he's coming from and suggest. But offhand, right now, I don't know क्या कर सकते हैं. Lot of activities which give a sense, and then of course also you need to, at some stage you need to be able to look at data which have been produced in experiments done by other people and be able to analyze them. So you can't always think you will do the experiment yourself. The first stage is that you do and you realize where data comes from. Because otherwise, if you just given always just given data produced by other people, you will not appreciate how it is generated or be able to rely on it. Once you realize how it comes about, what are the limits within which the accuracy and things like that, then so yeah, I don't think I have been able to answer your question, because I really have to think about क्या क्या कर सकते हैं.
Can I
हाँ.
comment? I mean, not really as an answer to your question, but a very general point, which is that whenever questions like these arise, why was it important, or why did they do what they did? In questions of this nature, I mean, trying to address questions of this nature, it's very important that we take a very historical perspective. Okay, so, see, whatever we learn in school, let's say our school is 10 years long, we are trying to squeeze in the entire progress of humanity and human thought into that short period, which is really, really impossible. So what is important to probably see is where did we start from, where we are today, for at least a few things, not everything of course, and maybe somewhere you find a cue, okay, this is what probably triggered a change, and maybe that's the kind of answer you should be looking for when talking to your brother next.
No, I have a suggestion for your brother. Very nice book by Bill Bryson called A Short History of Nearly Everything. Maybe when in his holidays when he doesn't have anything else going, he should read that.
You had a question.
Yeah.
Huh.
So my question is more about. So we have. I'm part of a group which works with college teachers, and we also. Yeah, so we work with college teachers and we also use misconceptions as a way to get them to appreciate that they need to focus more on the process and not just the facts. But my question is similar to what Supriya asked, how to sustain this effect? In the sense, after the workshop, maybe some teachers would take efforts to do something, but it fizzles out. So how frequently would a same teacher undergo teacher training in the HSTP, or what was that time or frequency worked out? And
So what we did in HSTP was basically we got the teachers to, any teacher who joined the program would be attending a 3-week long workshop every year for 3 years. Because in class 6, you first do classic experiments, in class 7, and then finally class 8. And then there would be also 1 day meetings in between when you do the experiment in the during the workshop, and then when you go to the classroom you realize something goes wrong and you need help. So this is what we learned from the HSTP experience, that one shot workshop does not help. You need a lot of repeated exposure. Also, not just like there shouldn't be a long gap between these workshops. So that's why, of course, the summer holidays is a good time to have a long workshop, but follow it up with at least 1 day or 2 day workshops in between. And also have a space where teachers can share their problems and the things that they discover and they learn, what they manage to do with others. So when they, after the first workshop, when they go back to the classroom and they're trying out things for the first time, they need a lot of support. So if you want to see results without that kind of support, it needs a lot more effort. So like we were working in Indore for many years. Consistently we would get the same teachers coming for workshops. And it was only after about 3 years or so that I saw teachers trying out those experiments in the classroom. But they still hadn't reached a stage where they would say, okay, light ka experiment kar liya, now let's try out the heat wala experiment. Because one thing is, of course, that the way the experiments are described in the textbooks are not sufficiently detailed to enable you to be able to set it up on your own. So unless you've had someone help you do that experiments, you don't know how to do it with students because you haven't done it yourself in school or in college. So so we in about 2-3 years you would reach a stage where at least the teachers are trying out things in the classroom. But it needs a lot more than that for them to be able to try out new things also.
yeah, and
You need to develop a lot of confidence for that.
And then if you're working with the same group of teachers over 3 years versus reaching out more teachers. So, I mean, that's the struggle which a lot of us face.
Quantity versus quality.
Exactly. So,
Okay.
I mean, how would we impact maximum students if we do this, like the same teachers over more years, or reach maximum? I mean, I don't know. It's an open question.
I know, but I would say quality because, I mean, just because you've got say covered 1,000 teachers in one workshop, and if maybe they enjoy the workshop, but if nothing is going to happen in a single classroom, not very useful, no? I mean, those 1,000 people have had fun, but they've enjoyed the whatever 10-day workshop or whatever, but nothing is happening in the classroom. Then we are not achieving what we set out to do. So I would say intensive is necessary. Because basically we are in all these workshops, we are trying to replace what they should have been doing in their school and in college, in the B.Ed courses, which has not happened. So now so that kind of, BSc 3 years plus B.Ed 2 or
Move your cell phone away.
1 or 2 years, that is what we are trying to make up. So you can't expect like 10 days ho jayega.
Okay, so I have attended many talks where people talk about like training teachers. So do you have any program where you train students, or you have 15 days long training program for students,
For
or
students.
1 month program kind of?
So Eklavya's philosophy has always been that if you, in a classroom, you can comfortably work with 30 to 40 students or teachers. So if you work with 40 teachers, they are able to go reach so many more students. So we prefer, like she's saying, where do we invest our time in? So we prefer to invest our time working with teachers in the hope that they'll go and impact so many more students' lives. But we do student workshops. That is also because we want to try out like the materials that we develop. We try it out with students to see whether it works, whether they're able to do the experiments, whether they're able to make sense of the experience. So we do workshops for students also, but it's not it is for our own benefit. It's not for, we don't work with students as such. We do a lot of things like Bal Melas and all, where we go to a new place and we are trying to build a relationship with the community, or for various other reasons, but our main focus is on working with teachers.
Okay, so how do you make sure that your program is fruitful? Means whether you take feedback from the teachers, means when they go to school, they must be trying those experiments that you have taught. So do you take feedback from them, means how the things are going, or you are trying new stuff or something like that?
So both in the when the Hoshangabad science teaching program was running, and when we were working with ashram shalas in Maharashtra, we had field people who were regularly going to each school and observing what is going on. We had in the ashram shalas we had done an initial survey in which we looked at what the teaching practice is normally like. Do the teachers just keep on talking? Do they take examples? Do they ask questions? Various things. What happens? What does a classroom transaction like? And then of course our field people were going to the classrooms and seeing whether the experiments are happening in the classroom. Initially, of course, they had to help the teachers a lot, but in the second year, we found a lot of teachers who were doing it on their own. Even when the field people were not in the school, they would be doing experiments. Unfortunately, because of COVID, the third year the project didn't happen, so we didn't do a post-test or things like that. But we were regularly visiting schools and seeing what the impact of the program is. And we got very positive reports from, not just the teachers, but even the ashram shala, the project officers and people like that.
Okay, so so the next question is like, so we talk about doing science, living science, okay, and so in our textbook we had lots of experiments written down, like which includes like basic stuff, balloons and other things.
Sorry?
Balloon and other things, but I never did experiment in my school, means no one was there. So is government helping or providing any facility to school or something like that? Means, do you know?
It varies from state to state.
Okay.
In Rajasthan, for example, they don't have labs up to class 10. They don't have practicals up to class 10. CBSE, of course, follows NCERT, which says activities are there. And I think CBSE schools are supposed to have a junior lab and a lab for for high school and all that. Whether you might have a lab, but whether the teacher actually takes you to the lab or not is another question. So Yeah, it varies from state to state, and it depends on the management, on various how comfortable the teacher is, on whether practicals actually happen, the children get to do things with their own hands. So, like, yeah, for more than 60 years, people have been saying, experiments need to be done, but I think it's just been becoming worse, because I remember asking my father once, and like how he was taught something, and he said that the teachers used to do demonstrations. And this is like I had also gone to see a very old school building in Raipur, and the teacher's table was, a big table made for doing a lot of demonstrations. So at one time things were probably better. At least, children, even if they didn't get to do things with their own hands, they got to see something happening. But then now we've reached a stage where unless you are in a very good school, you don't do anything at all, which is really sad. And it's actually very, like you're saying, no, simple experiments with balloons, so easy to do, but they don't do it.
Last question.
My question is that India is the largest population in the world, right? But the quality institutions that we have in India, like IITs or IIMs or ICERs, they're really a handful. You can count them, and their intake is very limited. So how can we educate people at mass? For example, trying EdTech is not good because the learning outcomes are not there. So the problem is that how can an institution like ICER, which has a current intake, how can it increase its intake without affecting its quality? How can it spread education among the more students?
Okay, I really don't know if there's any answer to this. I mean, I think you need to look at it two levels. One is increasing the number of institutes like ICER, but there's also the basic thing of ensuring that basic school education happens properly. So even if you have, like, for example, increase the number of students getting into ICER, whatever the number is today, make it 1,000-fold. Will you be able to get students to fill those positions, fill all those vacancies? Because, I mean, children who are coming out of class 10 and want to do science are very few. You are just looking at the number of children who are writing various entrance exams, but the number of dropouts after class 1, after class 5, after class 8, those are children who are not reaching anywhere near ICER. So before increasing the number of seats in ICER, you have to ensure that there are people who want to, that many people who want to do a course like in ICER. That is not happening. Children are dropping out of school.
That's an entire different thing. I'm asking that many people want to come, right? But it's an optimization problem that we have limited resources, but we want to serve those resources to most number of people. So how can we do that?
Like, well, I really don't
any
think
new ideas there.
I really don't
For example,
think
people thought that EdTech was the answer.
No, I don't think it's a question of limited resources. It is a political will. Where do you want to spend the money? Will you buy a fighter jet or will you build a school? I mean, for the price of a fighter jet, you will be able to build many schools. So it is not lack of money. I mean, just look at all the scams that are happening. How many hundreds of crores? So there's no lack of money in India. It is where you want to spend the money.
For example, let's take an instance that I want to build a education startup, and my optimization, my goal is that I want to optimize the learning outcome of the students, and these outcomes will be obviously be visible down the line with the quality of students that I will produce.
I mean, provided you get it right.
Yeah. So there is one normal approach that we take. Like there's a classroom, there's teacher teaching. The second approach is that you take this classroom, do it online, right, in video format. But we have seen that both these approaches had their own downfalls, right? The classroom approach is that you need a lot of resources to do that. And the second approach, like Khan Academy or like simple YouTube, the learning outcomes are not there. So how can we bridge that gap, that we have learning outcomes and we are able to like increase spread education among the masses?
I'm not at all a fan of replacing the teacher with anything on a screen, whether it's a YouTube video or whatever. The problem with YouTube videos primarily would be, the child being able to select which is the right video to look at. So, YouTube or anything on the net is problematic. So, I would say you would need to invest in building more classrooms and ensuring that the classrooms are staffed by sufficiently trained, experienced teachers, sufficiently prepared, capable teachers. I seriously don't think there's a shortcut. You cannot, if you want to educate 1,000 students, you need maybe minimum 50 teachers. You think you can take one very good teacher, shoot a video and send it to all these kids?
Yeah, that is right, because the learning outcomes are not there in that
I think we can
condition.
break the first discussion. Small.
So, these workshops, did you target these pre-service teachers like this MEd or BEd?
No, we've been consistently working with in-service teachers. We have not prepared any pre-service. Actually, we have not done anything like that. We have worked with producing, various states. They develop their DEd materials, so we've helped in that. But we have not done any pre-service.
It's like adding some curriculum into that structure or coursework.
Like in Chhattisgarh and all, when the DEd curriculum was being developed, we were part of that process. But we don't do. If you want to conduct a pre-service course, you need to be able to provide certification. So that is the whole, process in itself. So we've not done that.
Thank you.
Thanks to all of you for very interesting questions and a lively discussion. Uma, thank you very much for leading this and also sharing with us some very nice experiences that you have had. This is not a topic that that dies off very quickly. I'm sure there'll be more questions among the minds of people here, which will probably remain unanswered. But let us all keep up the hope that
Keep questioning, keep asking
that we
questions.
can do something better. Okay. Thank you all and good night.